Okay, so Leetcode practice time. So today, two goals within the video. The first one is to see how to solve this problem properly and put in some solid code there. And the other purpose is to see how to solve this problem during a coding interview. So let's get started. So always remember the first thing in a coding interview is to try to understand the problem. If there's anything unclear, please bring up the questions to your interviewer, and also think about the edge cases at the very beginning, which could be special during the processing time. So let's take a look at this question. So find all the anagrams in a string. So first of all, what is an anagram? So let's Google it, anagram. So an anagram is a word or phrase formed by rearranging the letters or of a different word or phrase, typically using all the original letters exactly once. For example, the word anagram can be rearranged into N-A-G-A-R-A-M. Also, the word binary into brainy, and the word Adobe into a body. Okay, so I think we understand what anagram is. So the question is, given a string S and a non-empty string P, find all the start index of P's anagrams in S. So strings consist of lowercase English letters, so only lowercase English letters. And the length of both S and P will not be larger than 20k 100. Okay, the order of output doesn't really matter. Okay, so I think since it says it is only lowercase alphabet, we don't need to worry about like illegal input, I would say. But definitely one edge case I can think about is, suppose the length of S is smaller than P, then actually you just need to return an empty result list. So that's the only thing I can think about the edge case. And the second step, after we fully understand the problem, is to find the solution for it. So what will be the solution? So of course you can go through. So you can try each. So you can try each start point within S, and try to extend it. Try to extend from the current start point to a substring which has the same length with P, and then do the comparison. And then do the stats on top of the substring. When I say stats, I mean the character and the corresponding frequency within the substring, and do the comparison with the corresponding stats with P. If it equals, then it is a anagram, otherwise it's not. So for example, let's say for this one, we extend from the current start point, which is this B, and we extend until we have a substring that has the same length with P, and currently it is BAB, and the frequency of B is 2, so it is not equal to the frequency of P, so of course it's not the anagram of P. But let's see, if we have this one, this substring CBA, so this one is an anagram of P, so we are going to insert the start index which is 0 into the output. So this one, I think it's a workable solution, but unfortunately it's not the best one, because the runtime is gonna be it's gonna be, suppose the length of S is M, and length of P is N. So this brute force solution is going to give us O, M times N, this kind of runtime. So let's see if we can do it any better. So actually, this remembers me a very common technique in string questions, which is called sliding window. So the sliding window is something like this. Suppose I have an input string, which is something like, I'll just use some dash to explain this. Suppose the input string is something like this, and each dash represent a character, and it could be whatever character it is. So in here we have a sliding window. So and so within the sliding window, we do the statistics of the character of the substring within the input, and then we do some comparison, and then we keep moving the sliding window towards the right side and keep updating the stats. So each time we just need to update the stats, a very small fraction of the stats, without doing like a restats on the whole substring. So that's essentially how a sliding window works. But sliding window can be different. So for example, the sliding window doesn't need to have a static length, depending on what the problem is. So it could be like the sliding window could maybe extend on the right or shorten on the left, depending on, it depends on the problem. But remember, for the sliding window, it is always moving towards the right side, and we are always maintaining some statistics of the substring that matches the sliding window. And every time we move the sliding window, maybe extend on the left, extend on the right, shorten on the left, or just moving the sliding window to the right side by 1, or sort of something like that, we just need to update the stats, a very small fraction of the stats, instead of generating a whole new stats for it. So that's what is a sliding window technique. So in this question, I would say we could definitely use a static sliding window. So let me use the example for you to understand. So let's say the input is this, and the input S is this, and P is ABC. So we are going to use a sliding window on top of this, on top of the S string. So first of all, we will do a stats on the P. So we will say, okay, the character A has frequency as 1, character B has frequency as 1, character C has frequency as 1. So we will have a sliding window, static sliding window with fixed length as 3. So every time we move the sliding window, we will have, suppose we initialize the sliding window as this. So we will have A1, B1, and C1, which matches the stats of P. So this one would be one of the anagram we are looking for. So we are going to insert 0, and then we keep we keep moving the sliding window to the right. So every time it's just 1, we just move it by 1. So here, since we exclude the C from here, we update C as equal to 0. So when it is 0, because it means there's no character within the substring, then we simply remove it, and we take the new character into the stats. So you see that every time we just update a small fraction of the stats within the sliding window, and it is going to take constant time. And the comparison, of course, it is equal to the length of the hash map. The number of the elements within hash map. But since there's a limitation saying that we only have lowercase English letters, then it means there could be up to 26 elements within the hash map. So the comparison between the hash map, the stats of the hash map, the stats hash map for P and the stats hash map for the sliding window, is the comparison between them is going to be constant, because at most 26 characters. So in this case, the runtime is going to be OM plus N, because first of all we run we generate the stats hash map for P, and then we move the sliding window from the beginning to the end it's something like iterating through the string s. So in total, it's going to be m plus n for the runtime. All right, so I think we find the solution, and the next part is about coding. So in the coding part, take care about the correctness of the code and also the readability of the code. Of course, don't be too slow. So let's do it. So let's see. So a list of integer. Let's say anagram index is equal to new linked list. This one. So first of all, we are going to generate the stats for p. So we are going to say, okay, map integer, character integer. Let's say p stats is equal to new hash map. So we iterate through all the characters within it. So let's see, car c p dot to car array, I think. Yes. So p stats dot put c p stats dot get or default, which is the c. This will be 0 and +1. Okay. And then we are going to iterate through the string s. So it's I will say in I is equal to 0, I is smaller than s dot length plus I. So yeah, so I think at the very beginning, it would be better if you can get the p length. I'll explain where it is going to be used. So let's say p dot length. Okay. And we also need to have a map similarly for the sliding window. Character and the integer, the sliding stats, new hash map. So okay, so car c is equal to s dot car at I. Okay, so if okay, so actually we just need to put sliding stats. Okay, we actually need to take a look at this. So if okay, we actually need to take a look at this. Yes, so p stats dot put the c as sliding stats dot get or default, which would be c and 0 + 1. Okay. Yeah, so now it's a time for, so if I would say if I is larger or equal to the p length, so that's the time we need to remove something from it. So if I is larger or equal to the p length, then I would say we are going to look at the character we need to remove. So we are going to say if sliding stats dot get s dot car at so it is I minus p length. If this one is a 0, then if this one is equal to a 1, then we just need to remove from it. So sliding stats dot remove, which is that, so let's say just we define another thing. Let's car to remove. Okay, so this one is going to be this. C to remove. We just reuse this character for the clarity of the code. And yeah, so otherwise we are going to have sliding stats dot put C to, it's not C to remove, C to update. Let's say C to update, because it may not be removed actually. So otherwise we will say we will put C to update as sliding stats dot get C to update and -1. Okay, and every time so every time if the I is larger than P length, that's the time we need to do comparison between the sliding stats with P stats. So if the P stats dot equals the sliding stats, so if they are the same, then it means we need to put something into the final anagram index. So anagram index dot add which is I, so it is okay, so it should be larger or equal to P length -1, I think. Yes. Yes. So it's gonna be I minus P length plus 1. So if it is equal, then the starting index of it is going to be okay, considering the I. Alright, so I think it should be that. And finally we return the anagram index. Yeah, so that's it. So after we are done with the code, it's now the end. We need to do some testing. So first of all, we need to do some sanity check. Sanity check by going through a example manually, and at the same time we are going to explain how this piece is going to work on top of the example. And also after that we are going to think about the test coverage by introducing some different testing cases to cover different branches. So let's say first one, let's use a very simple example. Let's say we have S as equal to AB and P is equal to AB. So first of all, we will have P stats as equal to A1 and B1. So that's the P stats. And then we are going to initialize the sliding stats as an empty thing, and we start from the beginning to the end. So the first character is A, and we put A1 into it. And since I is not larger than P length or P length -1, so we are not going, so I is equal to a 0 and the P length is equal to 2. So we are not jumping into those two if branches. And the next time we will have I as 1 and we have the B1 in the sliding stats. It's not going to jump into this if branch either, but it's going to jump into here. So we see that AB, we said that the frequency for AB are matching, so P stats and sliding stats are matching. So we are going to put a new thing into the anagram index, which is I minus P length plus 1, which is 0. So 0 is definitely here. And then next time when I is equal to 2, we are going to update the sliding stats as a2, right? And then we see that it's equal to the p-length. It is jumping to this if branch. So we see that the C2 update is this character is A. So we are going to see if the frequency is equal to 1. Because it's not equal to 1, which is it is equal to 2. So we are going to update this one as 1, the A frequency as 1, which means we are going to remove the first character from the sliding window. And we see that after that it matches with the p stats again, so we are going to insert the element, which is 1, 2 minus 2 plus 1, which is 1, into the anagram index. So similarly, we are going to insert another element, which is 2, when I is equal to 3 into it. So that's it for this piece of code. I think it should work. Let's give it a shot. Okay, some compile arrow. Okay, this dot remove. Okay, so some typos here as well, and the sliding stats, so cannot find the okay, so another typo here. Alright, so now it's accepted. Let's give a submission for it. So okay, so I think we are done with this coding question mostly. So I would say regarding the test coverage, so there are two things I can think about. The first one is the edge case, which means the s.length is smaller than p.length, and the other thing is some general test cases. And within the category of the general test cases, I would say definitely have something that has more than one index for the anagram, and also maybe have another thing that has 0 anagrams within S. So I would say that should be good enough regarding the test coverage, because it's going to cover all the if-else branches. Okay, so that's it for this coding problem. If you have any question, please leave some comments. If you find this video helpful during the preparation for your interview, please give me a like, and I'll see you next time. Thanks for your time watching this.